The next module is the scanf function. I'm introducing a new function to you from the standard C function library. Scanf is quite similar to printf. However, scanf reads information from the keyboard, whereas printf prints it out to the screen. Here's our old Hello World program again. I've saved this one as hello3.c. I'm going to now enhance this program by introducing scanf to read in, let's say, an age from the keyboard. I'm going to ask the user of the program how old they are. They will enter their age, then I'll print out their age. And we'll store their age in the variable called age, just as we did before. So we invent a new variable called age, like so. We can keep the words hello world, and then the next step is we're going to read in their age. Now, I could just do the scanf at this point here. However, what would happen then is the program would pause and wait for keyboard input. But the user would not know what they were supposed to enter. All they'd see would be the words hello world, and suddenly the program would be waiting. They wouldn't know that they're supposed to enter the age. So in order to make the program a little bit more user-friendly, we're going to add another printf, just like the first one, that says something like, please enter your age, a colon and a space, and then that is the end of the string literal, that's the end of the printf function, and a semicolon on the end. And as you can see, that it's very, very similar to the previous printf. It just prints out those words on the screen. However, there's a slight difference. There's no \n. The \n is because I do not want the cursor now to be flashing on the next line. I want the cursor to be flashing immediately after the colon, or rather, immediately after the space. So as you can see, the \n is not mandatory. It's not required in a printf statement. Sometimes you use it, and sometimes you don't. So now that we've told them what they're supposed to enter, now we can use the scanf function to read that information from the keyboard. And again, we use the string literal, and again, we use what we used before in the last exercise, a %d, to read in information from the keyboard. And again, we store it in the age variable. Now, that line is not quite right yet. Before I tell you what's wrong with it, I want you to compare it to what we used a moment ago in the old printf function. We typed in something like your age is, or my age is, and then a %d, and then a comma, and then the word age, the variable age, which worked. And this is essentially the same thing. It's a %d followed by a comma followed by an age. However, this will not work. It's almost right, but it's not quite right. And the reason it's not right, well, it's actually quite a complicated reason, which has to do with pointers and memory addresses and so forth, and I don't want to go into it at this stage because it's just going to confuse you. So what I'll do is I'll show you how to fix it by putting an ampersand right there just before the word age. That will fix the problem. Now, why that will fix the problem is, as I said, complicated. So please, I ask your forbearance. I don't like doing this. I don't like just asking you to memorize things, but please just memorize that when you use scanf, you put an ampersand before the variable name. And when you use printf, you don't. This will become clear in a later chapter. You'll fully understand why. But for the moment, please just memorize it. Okay, so we've read a value now, theoretically, into the variable called age. Now we want to check that it worked. We want to, let's say, do another printf to see if the age is in fact correct. So we do it like this. Printf, the age you entered is, and again, %d. This time we can put a \n on the end, and a comma, and then age. Notice there's no ampersand. Ampersands are only used with scanf. Well, sorry, when it comes to printf and scanf, they're only used with scanf. Ampersands are actually used quite a lot, but we'll learn about that when we get to pointers. Okay, so that's the program working. Let's see if that actually runs. Firstly, we'll compile it. 0 errors. Excellent. We're on the right track. Let's try and run the project. Okay, please enter your age. 36 is a good enough age as any. Press enter. Something's not right. The program disappeared. Why did it do that? Can you guess? I don't expect you to know the answer to this. It's not obvious. In fact, it's very peculiar. And it has to do with the interaction between scanf and getchar. They don't work very well together in the same program. As you recall, the getchar is there so that there can be simply a pause before the program disappears. And the pause is just waiting for you to press enter. And as soon as you press enter, the program ends and the window disappears. Let's see what's exactly happened here. The scanf function is called, and it reads a number from the keyboard. In other words, the program pauses, waits for you to start typing things. You type in 36 and press enter. What scanf does is it reads the 36 that you just typed and puts it into age. This %d means read a number, so it reads a number. What it doesn't do is it doesn't read the carriage return. Can you see where this is going? It doesn't read the carriage return. Then the program goes to the printf, prints out the age you entered is 36. Then we get to the getchar, and the getchar's sole purpose in life is to read a character. And so it reads the carriage return that didn't get read by scanf. You typed a carriage return after you entered 36, or I did anyway, but that carriage return never got read by scanf. So it gets read now by getchar. So what's the solution? Maybe put another getchar in. Well, you could do that. But there is a slightly more standard solution than putting another getchar in, and it's the following. I'm going to put an F flush of stdin in there. And the purpose of the F flush of stdin is to flush away any characters that have been typed in by the keyboard but have not yet been read by the program. In other words, the carriage return. Just get rid of them. Flush them, almost like flushing them down the toilet. They don't exist anymore. So when the getchar is next called, there won't be any characters sitting around for it to read. Now, this is a ugly and clunky solution to the problem. The problem is that getchar and scanf don't work very well together. And this is not a very nice solution to the problem, but it will do for now. There's still one problem remaining, which is also not obvious, and that is that the program won't compile as it stands at the moment. I'll prove that to you. Compile for errors stdin undeclared. Okay, so it doesn't know what stdin is, and that's okay. I was expecting that. So now we cause the program to know what stdin is, and this is how we do it. We do hash include stdio.h. It's not stdin.h, it's stdio.h. Now this is starting to look very complicated. Because of a simple clash between getchar and scanf, we've had to introduce all these extra things, an F flush, a stdin, a hash include stdio.h. Surely this is getting a little out of control. Well, it's not really. As you'll see as we go along later on in this course, these hash include lines are actually very common. In fact, I really should have had one there right from the beginning, right from the very first Hello World program. There should have been a hash include stdio.h there. I could get away with it, and I knew I could get away with it, with not having it there. And I chose to not have it there because I didn't want to confuse you at the time by having to explain what it is. And I'm not going to explain what it is now. We will talk about hash include statements a lot later. For now, I just ask that you include stdio.h at the top of your program anytime you use a printf or a scanf or an F-flush or a getchar or even the word stdin. All of those require stdio.h to be there. Actually, require is a bit too strong a word. They prefer it to be there. If it's not there, they can sometimes get away with it. But in this case, stdin is undeclared. You can see that we couldn't get away with it. So this time we do need it. The reason that stdio.h is preferred is that it contains a number of prototypes. We'll be discussing prototypes in a later chapter. But for now, please understand that stdio.h is almost always a requirement of a C program, especially a C program that uses printfs and scanfs. So theoretically our program is complete now. Let's compile it and test it. First we compile. 0 errors, excellent. Next we run. Hello world, please enter your age. Well, we got this far before, let's see if it's better this time. Please enter your age 36. The age you entered is 36. Okay, we didn't see that before, and now it's waiting for me to press another character. So I do, and the program goes away. Everything is working.